Our galaxy is vast. It stretches across the night sky, a sprawling collection of stars, planets, and cosmic wonders that boggle the mind. When we look up, we see just a fraction of its grandeur. It's filled with billions of stars, each one a potential sun, each one a beacon of light in the darkness. These stars are not just distant points of light, they are the birthplaces of planets and possibly life. And around many of those stars, we're finding planets. These planets, known as exoplanets, orbit their parent stars in a dance that has been going on for billions of years. Some of these exoplanets are rocky, some are gaseous, and some are in between. These planets are called exoplanets. They are worlds beyond our solar system, each with its own unique characteristics and mysteries. The study of exoplanets is one of the most exciting fields in astronomy today. In 2015, astronomers made an exciting discovery. Using advanced telescopes and techniques, they identified a new exoplanet that captured the imagination of scientists and the public alike. They found an exoplanet called K2-18b. This planet, located many light years away, quickly became a subject of intense study and speculation. K2-18b orbits a red dwarf star called K2-18. Red dwarf stars are the most common type of star in our galaxy, and they are known for their long lifespans and stable energy output. This star is much cooler and smaller than our Sun. Despite its size, it provides enough warmth to its surrounding planets, creating environments that could potentially support life. K2-18b was discovered by the Kepler Space Telescope. This remarkable instrument has revolutionized our understanding of the universe by finding thousands of exoplanets. This telescope was specially designed to find exoplanets. It uses a method called the transit method, which involves detecting tiny dips in the brightness of stars as planets pass in front of them. It did this by observing tiny dips in the light of stars as planets passed in front of them. These small changes in brightness can reveal a lot about the size, orbit, and even the atmosphere of the exoplanet. The discovery of K2-18b sparked great interest among scientists. It opened up new possibilities for understanding the conditions that might support life beyond Earth. It orbits its star in the habitable zone. This is the region around a star where conditions might be just right for liquid water to exist, which is crucial for life as we know it. This zone is the region around a star where temperatures are just right for liquid water to exist on a planet's surface. The presence of liquid water is one of the key factors in the search for extraterrestrial life. And as we know, water is essential for life as we know it. The discovery of K2-18b in the habitable zone raises the exciting possibility that this distant world could harbor the conditions necessary for life to thrive. K2-18b is bigger than Earth, but smaller than Neptune. This intriguing exoplanet falls into a category known as Sub-Neptunes, which are planets that are larger than Earth but not quite as massive as Neptune. These planets are fascinating because they offer a glimpse into the diversity of planetary systems beyond our own. This makes it a Sub-Neptune. Sub-Neptunes are a unique class of planets that are common in our galaxy but absent in our solar system. They're characterized by their size and mass, which place them between the smaller rocky planets and the larger gas giants. It's about 2.6 times the radius of Earth and has about 8 times Earth's mass. This significant difference in size and mass means that K2-18b has a much stronger gravitational pull than Earth, which could have interesting implications for its atmosphere and potential habitability. This means K2-18b is much denser than Earth. The density of a planet can tell us a lot about its composition. For K2-18b, this high density suggests a rocky core, possibly surrounded by layers of ice and gas. Understanding the density helps scientists make educated guesses about the planet's internal structure. It likely has a rocky core surrounded by a thick atmosphere. This thick atmosphere could be composed of hydrogen, helium, and possibly water vapor, creating conditions that are vastly different from those on Earth. The presence of a thick atmosphere also raises questions about the planet's climate and weather patterns. Sub-Neptunes are a common type of planet in our galaxy. They are found in a variety of star systems, often in the habitable zone where conditions might be right for liquid water. This abundance makes them a key focus for astronomers studying the potential for life beyond Earth. But they don't exist in our own solar system. This absence makes the study of sub-Neptunes even more intriguing, as it suggests that our solar system is somewhat unique in its planetary composition. Understanding why sub-Neptunes are missing from our solar system could provide insights into the formation and evolution of planetary systems. This makes them fascinating objects to study. Scientists are particularly interested in their atmospheres, compositions, and potential for hosting life. Advanced telescopes and space missions are continually gathering data to help us understand these mysterious worlds. They bridge the gap between small rocky planets like Earth and gas giants like Jupiter and Saturn. This intermediate position makes sub-Neptunes a crucial piece of the puzzle in our quest to understand the diversity of planets in the universe. By studying them, we can learn more about the range of planetary environments that exist and the potential for finding life elsewhere. K2-18b orbits its star in the habitable zone. This zone is also called the Goldilocks zone. It's not too hot, not too cold, just right for liquid water. Liquid water is essential for life as we know it, so this zone is where we're most likely to find life beyond Earth. However, just being in the habitable zone doesn't guarantee a planet can support life. Other factors like the planet's atmosphere are crucial. In 2019, scientists used the Hubble Space Telescope to study K2-18b's atmosphere. This was a significant achievement. It marked the first time we analyzed the atmosphere of a planet in the habitable zone of another star. Hubble detected the signature of water vapor in the atmosphere of K2-18b. This discovery was a major breakthrough. It hinted at the possibility of clouds and even rain on this distant world. However, Hubble's observations were just the beginning. We needed a more powerful telescope to unlock the secrets of K2-18b's atmosphere. Section 5. A new era of exploration, the James Webb Space Telescope. Enter the James Webb Space Telescope, or JWST. Launched in 2021, JWST is the most powerful space telescope ever built. It observes the universe in infrared light, which is just perfect for studying exoplanet atmospheres. JWST set its sights on K2-18b, and it made groundbreaking discoveries. Section 6. The breath of life, detecting methane and carbon dioxide. JWST detected methane and carbon dioxide in K2-18b's atmosphere. These gases are significant because they can be produced by living organisms. On Earth, methane is released by microbes and carbon dioxide is exhaled by animals. Now, this doesn't mean we've found life on K2-18b. These gases can also be produced by geological processes, but their presence is intriguing. It fuels our curiosity about the possibility of life beyond Earth. Section 7. Hycean worlds, a new hope for life. K2-18b's size and the presence of water vapor in its atmosphere suggest it might be a Hycean world. These are hypothetical planets covered in vast oceans. They have atmospheres rich in hydrogen, hence the name Hycean. Hycean worlds are of great interest to astrobiologists. They could potentially support life as we know it, even if they are very different from Earth. Section 8. Seeking answers, the significance of biosignatures. Scientists are searching for what we call biosignatures. These are chemical fingerprints that could only be produced by life. One such biosignature is dimethyl sulfide, or DMS. On Earth, DMS is produced almost exclusively by marine phytoplankton. If JWST detects DMS in K2-18b's atmosphere, it would be a strong indicator of life. Section 9. A universe of possibilities, the future of exoplanet research. The quest to understand the cosmos has always been a driving force for humanity. From the earliest astronomers who charted the stars to the modern-day scientists who use advanced technology to peer into the depths of space, our desire to explore and understand the universe remains undiminished. The study of K2-18b is just the beginning. This exoplanet, located in the habitable zone of its star, has captured the imagination of scientists and the public alike. With its potential to host liquid water, K2-18b represents a tantalizing possibility in the search for life beyond our solar system. The James Webb Space Telescope will continue to observe this fascinating exoplanet. Equipped with cutting-edge technology, it will provide unprecedented insights into the atmosphere and composition of K2-18b. This will help us understand whether conditions on this distant world could support life as we know it. It will also study many others. The James Webb Space Telescope is designed to explore a wide variety of exoplanets, from gas giants to rocky worlds. Each new discovery adds a piece to the puzzle of how planets form and evolve, and whether they might be capable of supporting life. As we peer deeper into the cosmos, we're discovering a universe teeming with planets. The sheer number and diversity of these worlds are staggering. Some are hot and inhospitable, while others are cold and barren. Yet among this vast array, there are planets that may have the right conditions for life to thrive. Some of these planets may harbor life, perhaps even intelligent life. The discovery of even microbial life on another planet would be one of the most significant scientific breakthroughs in history. It would fundamentally change our understanding of biology, evolution, and our place in the universe. The search for life beyond Earth is one of the most profound scientific endeavors of our time. It requires the collaboration of scientists from many different fields, including astronomy, biology, chemistry, and planetary science. Together, they are developing new techniques and technologies to detect signs of life on distant worlds. It is a journey of discovery, of pushing the boundaries of our knowledge, and of seeking our place in the grand tapestry of the cosmos. As we continue to explore the universe, we are reminded of the vastness and beauty of the cosmos, and of the endless possibilities that await us among the stars.